Hey there, it's me, Frame, and in this video I'm going to show you an exciting new tool for tasking Super Mario 64 that I've been working on for the past half year or so called the Semantic Workflow. With it, I've created my submission for the 2025 task competition Task 7, which you can see on screen right now, and we'll also see how we can recreate the winning run for that competition by FeijoadaMolhada later in this video, so let's dive right into it. All right, so what we have here is the Semantic Workflow project that I used to create my submission for the task competition. As you can see, this is a page in the SM64 inputs Lua. You can get that from GitHub, link in the description. And as you can see, this page is divided into 3 different tabs: project, inputs, and preferences. And for this particular project, you can see it's divided into 4 different sheets that we can just run back to back. The first one is just, warping to get the run set up. Then from there, we're breaking the first 2 boxes. And we're moving into the movement for a flying triple jump, FTJ. And from there on, it's just the finish. Now, before we get too deep into how to actually use this tool to create runs, I want to mention that each of these tabs has a dedicated help page that should help you set up and get started. And information like recording M64 files, all that good stuff, how to use this rather complicated editor, what the preferences mean, all that good stuff. And with all of that out of the way, let's take a look at what this actually is and how it works. So let's take a look at how one of these sheets is actually constructed. I'll click on the FTJ, the flying triple jump sheet, and then head over to the inputs tab. And what we can see here is that this is subdivided into sections that go on until something happens. So for instance, this starts right here at this upslide part, and then the first section goes until we get air hit wall. So I'm going to click on the red section here of the second section to set the preview frame. And you can see it goes up until the air hit wall, and then it does one more input, the A button input here for the wall kick. And then it goes on like that. We just hold that out for 3 frames, then we release it, and then when we go for the next section, we've got the jump land now, so we're in that action now. And every time I click on a new preview frame, I get the game is rerun up until that frame. Now I can also set the preview frame to something that's in the middle of a section. And this one in particular is interesting because it says idle, but we're not actually ever going to be idle here. What happens instead is that this section times out. This just holds out for 13 frames. The reason I've done this is because I need to release A after a while, and you can see that we're holding the A button here to do the slower wing cap falling. And then the next section is the one where we're not holding A anymore. This one goes on for at most 50 frames, but it's actually being ended by the double jump land because we're actually waiting for a double jump land here. So that's how the run is divided into sections. And now for each section, I'm going to turn fast forward on because we're going to take a look at how we can edit things here now. So say, for instance, I want to be a little bit more to the right here. Then I could choose to not go to the left so much before, and just edit that in the past from the previous section. You can see we're getting the results immediately. Now I could want to go a little bit more to the left, and if we go just a bit too much to the left, you can see it now takes a frame longer with this ghost in comparison to actually get there. And that's what it means that this is semantic tasking. We're not going for a fixed number of frames here. We're going until jump landing. Now we've probably noticed that this section down here looks a lot like the TAS page here that you might be familiar with already. And it's basically what it is. We're not authoring inputs like in an M64 file where it's the X and Y coordinate of the control stick. We can do that if you want by switching to manual here and then, just dragging that. But it's usually a lot more helpful to phrase things in terms of angles relative to Mario's currently front-facing angle, or just, facing angle, like exactly. And we can do all sorts of stuff like 0.99 straining always. This doesn't really have an effect here right now because we're way too fast for that. Now, what's important here is that this area down here is always going to show the state of just one frame. And that's the one highlighted in green up here. That's the active frame. And whenever I change anything here, like the state from match yaw to match angle with the yaw again, then what it's going to do is it's going to copy all of that state to these green joysticks, the frames that have these green joysticks. So like all of these are doing a slightly different thing now. You can see this last one here is showing a different direction depending on whether I click this preview frame or this preview frame. That's because it's holding out up until the next section. It's going to keep that state until that section ends. That's the last frame of a section, is going to keep that state. So changing this is way more important than changing this. Like you can see the difference is very, very minuscule here. I can also change the active frame without changing the selection if I want by clicking in the middle column here. I can make sparse selections by dragging over as many inputs as I want and then holding control and, click on this input that represents an entire section way later in the run. I will see what that is. That's until we land here, and then we can just, I guess, do this. Now we've got a really, really crazy strain in the middle of the run. This probably doesn't make much sense to actually use it like this, but we can. And if we, do something too crazy, then eventually this entire thing is going to fall apart because we're not landing where we want to anymore. Special triple jump. I didn't know I had that save state. Anyways, that's the basics of how this works. Now, the last thing I want to show off before we get into recreating the winning run of the competition is how to turn the semantic workflow sheet into a .m64 file that I can actually submit to the competition. And this is actually really easy. All I need to do is just load the save state from the competition, and then I'll start recording a new movie from here. So this will be our result.m64. And I will just click this play without loading ST button for each sheet in order, like so, and stop recording. And that's it. That's all there is to it. I can play this back with a lot of lag, so yeah. And next we're going to give recreating the winning run of the competition a shot, shall we? So usually with a project like this, I will first start recording a ghost of the run I'm up against. I can actually fast forward during that process, as you can see here, and only then will I open the Lua and start working on a new project. So what I'm going to do is to load the save state from the TAS competition, and then I will create a new project in a new directory where I will set up a Git repository in a moment. A Semantic Workflow project consists of the project file itself and several files for the sheets and their respective associated save states. So keeping things in a dedicated directory is a great way to keep things organized and to share your progress with other people. And now let's get started with our first sheet, which is going to be our setup sheet. Just left click that, and then I'll add 3 sections. I'm going to wait for the teleport fade in action, And then after that, I will add another section that just waits for a couple frames. As you can see here, just so we have a little nicer starting point here. And the last section is just so we have something we can preview. Now, after this quick setup, I also want to turn the ghost tag and the previous position tag on. So I'll set the preview frame as the first frame of the sheet, then turn the hacks on in Stroop, which you can't see me doing here because that's not the focus of the video. And then I'll just hit this .st button over in the project page, which will make the sheet start from the current state of the game. This works as well as it does here because we're just waiting to warp anyways, which will lead to a consistent state after the warp regardless of when I start. And SM64 has lots of those transition points where you can get a setup like this, like paintings or level transitions of any sort. At this point, it's a good time to save and initialize our Git repository already. I'll just hit save, then open a Git console in the directory I placed the project file in, do git init, git add dot to add all the files, and then git commit to complete the setup. Now, all of this Git stuff is optional, but I find that it really gives me confidence that I'm not losing any work even when I make the most disruptive changes. So if you're well versed with Git, I really do recommend using it. And with all of that out of the way, it's time to start on my first real sheet. Ignore the Super Mario 74 jump scare here. I'll just run the setup sheet I just made and click the .st button again, like I did before, to fix that. And so with this sheet, I'll go for the first wing cap box. So I'll just name it first box. This time, I'll actually wait until the idle action, which is what a section ends on by default, then match the angle of the ghost, and then turn for a few frames until I'm able to long jump. Now, the action I wait for after idle will be long jump land because I'll get into the long jump itself within this section. I'm also doing my Stroop setup during this, but since that's not the focus of the video at all, I'll just fast forward over this real quick. So now, as you can see, I am already long jumping and I want to follow this up with another long jump immediately. So what I need to do is to release the A button by the end of the previous section so that I can press it again once I land. And now to get over to where the reference run ends up in, I'll strain to the side, but that alone isn't going to be enough. I'll actually be doing an arctan strain, which is especially easy to use in this workflow, so you just watch. I'll click the Enable button on the arctan controls, then hit the Retime button, followed by selecting the frame the arctan strain starts, and then the frame just after the arctan strain, meaning that that frame isn't going to be included in the strain. And this will set up the timing parameters for me automatically, which has been super confusing for me in the past. And now I can just scroll through the angle values to get a good match, which is actually a bit ahead already. Next, I will go through a similar procedure for the wall kicks up ahead, so I just create a section that ends on air hit wall and then press A on that next section. But here I run into a bit of a problem. For the next wall kick, I want to release A exactly one frame before hitting the wall, because Mario is gaining significant height the entire time here. So instead of waiting for air hit wall again, I need to time this section out after 10 frames in this case instead. And then on the section after that, I will add one frame at the start where I'm not pressing anything, and then A to perform the wall kick. From here, this next section will go until jump land, and I will need to hold out A for a couple of frames to reach the height, but not fully. So when I add the next section after that and preview it now, this doesn't give the desired result because Mario is bonking into the box. So again, I need to release the A button at an appropriate time, and I can also do this by adding a bunch of frames to the start of this section. And this one here, I've actually gotten one too many in here. By the way, you can also just frame advance through this by pressing the frame advance button. So what I'm going to do is I'm just going to delete one of the A holding frames and we'll get the jump like we want it. Next up, I'm going to do a side flip into the box, and for this I want to enter an absolute facing angle, not a delta towards Mario's facing angle or just some random whatever input, because this is a point in the run where a lot of things come to a full stop, namely Mario's speed, position, and angle. And I want to focus on where I'm going next rather than where I came from. Normally, just using the input direction tools, this doesn't matter much because the information is lost once the recording is finished. But here it is going to be kept in the project files, and we may benefit from knowing the exact targeted angle later. And now I'm just going to fast forward through finishing up the sheet, which will end up sliding on the hill to the left, all the while tweaking angles for individual sections and frames to get a good match on the reference run. You can see I've also installed a track of the wing cap hitbox to make sure I collect it efficiently, and then after a bunch of more tweaking, I end up with a pretty good run up to that point. So after this good amount of work, it's a good idea to save and commit again. Like before, I just hit save, open my trusty Git console, add all the files, and commit. And now I will go on with the remaining sheets, which I won't explain in as much detail, but I will stop occasionally for when something interesting happens. The next sheet is gonna be for the flying setup, which involves some very annoying sliding and a glitchy wall kick on the moving platform. The run I'm going up against is very strong, so especially matching angles to a team is extremely important here, but also speed. I cannot afford to lose pretty much any speed at all while getting the desired angles, which, as we'll get to see in a moment, actually means I'll have to work on the previous sheet again. But first, I create the sheet after that, dedicated to the flying part of the run to see how close I can already get. So this is when I decide that I need to edit the end of the sheet for the first box again to get the required angle without losing too much speed on the slide. And what that is going to do is make the glitchy wall kick sheet not stitched correctly anymore. So to fix this, I head back over to the project tab and let the first box sheet run to its preview frame and then hit the .st button, like I did before, to change where the glitchy wall kick sheet starts from. After that, I'll have to adjust the glitchy wall kick sheet again to make it actually glitchy wall kick as it should. But this time I can end up with a little bit more speed, hopefully. Unfortunately, that still doesn't quite make it, even after repeating this procedure an honestly frustrating number of times. This reference run is really strong, and I need some more time to get all of that matched up sufficiently. But again, I've made sure to save my progress regularly up to this point. So for this flying section, I'm using regular manual inputs, not match angle or anything of the sort, because flying just does not depend on the camera at all, actually. And it's really nice that I can see the effects that changing an input in the past will have several frames later, because for flying, that's normally really, really difficult to predict. It's still very hard to get all of this right, and I still have to jump back and go back in time sometimes to adjust the glitchy wall kick to get that extra bit speed. But eventually I do manage to make it and match the reference run on that very, very tight landing frame up there. Finally! From here on, it's going to be relatively smooth sailing, I think. And indeed, it does go rather smoothly for a while, but right at the end here, I'm just about to grab the star, and for some obscure reason, I end up just a few units short. Just like before, the reference run seems to be getting units out of nowhere, and in this case, it's indeed very easy to miss. There is a speed kick in there, and doing a speed kick at different camera angles will yield different results, both in terms of direction and speed, because the input magnitude is so low. Thankfully, we can make adjustments to the camera on nearly any frame we want in the past with this workflow, so it's easy to fix this up, get those magical units, and grab the star in the same frame as the reference run. Now I just add a section until start ends exit, and one more after that, which I time out after 111 frames, which is when the screen is completely black, purely for aesthetic purposes, and with that, the actual recreation work is complete. All that's left to do now is to turn this into an M64 file. And I'm going to do just that, like we saw before, by loading the save state from the TAS competition. Movie, start movie recording from save state. Result. And done. That's as much as I can show today. I hope I've piqued your interest with this, and if you want to try this out for yourself, you can find the link to the GitHub page in the description. I'd love to hear your feedback, either here in the comments, on GitHub, or in any of the various Discord servers that I regularly hang around in. Now, before ending this video, I want to point out some subtle changes that the keen-eyed of you may have already noticed. In the beginning of the video, the Arctan controls were a little bit different, and just now, there's a small version number visible in the top right corner. And what this means is that I've continued development of the Semantic Workflow during the production of this video, and I have no intention of stopping here. While I'm proud to show off what I have in store today, there are countless ideas and potential improvements to make, like section pre-buffers, allowing things like releasing a button 2 frames before a section starts. This will be implemented using in-memory save states. Speed-based section termination, so you can, for example, 0.99 strain and choose to do something different from there. Dedicated sections for special tasks, such as automated dive grinding. Semi-automatic conversion from M64 files to semantic workflow sheets. Git integrations for easy strat comparisons, undo, redo, and so on. And all the small things that make life easier, like hotkeys, section names, custom themes, etc. You can follow my development in the mupen64 Discord or on GitHub, and maybe even contribute to the code if that's up your ale. Finally, I want to give a big shout out to Arrowmaker, who is the original author of the SM64 Lua Redux script. He's been incredibly supportive during the development process of this tool, and it would not have been possible to create this without the amazing foundation that he's laid with the Breitband graphics and the UGUI projects that power the script, as well as the continuous development of mupen itself. Speaking of, you will at least need mupen 1.2.0 for this to work, as this script makes use of an in-memory save state API that did not exist before. So if you're an update slog like me and still on mupen 1.0.7 or something, this would be a good reason to upgrade. Okay, that's it for real now. Thank you for watching, have an epic day, and happy TASing.